So we're going to go over lesson 3 here today, which is basically volume of prisms, cylinders, pyramids, and cones. So we're going to start off with the different type of prisms. So a prism is basically a three-dimensional solid where the top or the bottom, so the things that we call the bases, are parallel, congruent shapes. So parallel means that they are in the same line as each other. Congruent means that they are the exact same size, exact same shape. On the lateral side, so the lines that actually connect them together right there, are rectangles, right? So a prism is named by the shape of its base. So for example, a rectangular prism here will have a rectangular base, right? A pentagonal prism that we have here will have a pentagonal base, right? Hexagon will have a hexagon as a base. Cube will have a square as a base. Triangular will have a triangle as a base. Okay. So the volume is the amount of space that it occupies. So basically, if you were going to fill up this prism with water or any other liquid or any other material, how much could it possibly hold is what the volume means. Okay. And so the one thing to notice here is that the rectangles are the same if you have a regular hexagon or a regular pentagon, right? These are all going to be the same. So these are all going to be the same, right? Another thing to keep track of is that, even here, like all of these are going to be the same. Okay, the things that are connecting them. And when it says something's in parallel, right? It's in parallel because if you look up from here, they're in parallel here. These are parallel to each other. These two will never meet their, like that. Okay, so that's that. So it's usually measured in cubic units. So we measure it as either millimeters cube, centimeters cube, meters cube, depending on what you are measuring, right? So the volume of any base is going to be volume of any prism is going to be volume is equal to area of the base. Area of the base multiplied by height, right? And the height is basically the height of the rectangles. So that would be the height. Height of the two, height is like the distance between the two parallel sides. Okay? So, the best way to go over this is to obviously go in and do the example questions. So, area of the base, I always write as A, B, because I just like having, shortcuts. And I always write H as capital H, actually. So this is capital H, height. Okay. So let's just go here and do the first one. So we know that volume is equal to area of the base multiplied by height, right? The area of the base is just the area of this rectangle down here, the shaded rectangle down here, which we know is length times width. So the volume of a rectangle is equal to length times width times height. We know my height is going to be this portion right here, 4. So it's going to be volume is equal to 6 times 3 times 4, right? And that's going to equal 72. And it's centimeters, so centimeters cubed. This one's pretty easy. We've done volume of a cube multiple times, right, of a rectangular prism. This is where it starts to get a little bit more complicated. So, first things first, let's look at what type of shape this is. This is a trapezoid, right? And it auto-corrected to a triangle, sorry. So this is a trapezoid. We know that this trapezoid, right, is the trapezoid over here as well. So if I was to draw this in, you would have a trapezoid here as well, right? So the two bases of this are a trapezoid. So this is what we call a trapezoidal prism. And off the bat, we actually don't have the formula for a trapezoidal prism. So how we would find this is we would use our volume equals area of the base is multiplied by height. So we got to figure a few things out. One, what is the height, right? So I know that this is my trapezoid, right? So if I go back and I look at my formula sheet, I know that the area of a trapezoid, so area of the base is the area of a trapezoid, is equal to A plus B, right? A plus B multiplied by height divided by 2. So we know that A is this 6 feet here. We know that the top part is 4 feet. And if they're the same thing, so we know that this is also 4 feet because they're the same thing over there, right? So that's the same length. So we know it's 4 feet. We know the height is also 4 feet. So let's just figure out what the area of the base is in the first place. So let's do A. So I'm going to say 4 feet plus 6 feet, right? A plus B times height, which is also 4 feet. So I'm just got to go erase that. Also 4 feet divided by 2. The 4 feet because look, it tells us the height right here, right? So I'm just going to do my math. Equals 10 times 4 divided by 2. 10 times 4 is 40 divided by 2 is going to give me 20. Right, so I got 20. So I know that volume is equal to area of the base, which I already figured out is 20, right, times height. My height is going to be 9 feet here. Do you see why? Because you're connecting this trapezoid to this trapezoid via this line over here. So it's going to be 20 multiplied by 9, and we know that is 180, and it's feet, so it's going to be feet cubed. And that's going to be my volume. Okay? So first things first, always find the area of the base. And you can find that by finding the area of that. We have formulas for it available to us, right, of the 2D object. Okay. So now, moving on. It always gets a little bit more complicated as we move on, right? So here we have our hexagon, right? When we remember back when we looked at our pentagon, and we don't really have the formula of how to find a hexagon, right? But when we looked at our pentagon in lesson 2, we saw that it was made up of 5 different triangles. So we're going to try to do something similar here. Let's look at how many triangles we can fit in here. This is 1, right? This is, oops. Sorry, just give me 1 second. Trying to figure out how to make this look nice. 2. So you have 1, 2, 3, 4, 5, and 6. So a hexagon has 6 sides. You could say that it has 6 triangles that make it up, right? So if we find the height of this one triangle right here, or the area of that one triangle there, right? We can now find the area of the entire hexagon by multiplying it by 6. So let's find the area of the base first. So area of the base is equal to 6 times base times height divided by 2, which is the area of a triangle. So we're going to do 6 times. Base is going to be whatever it is across, so it's 13, right? Because all of them are 13, times height, which is 11, right? And I'm just going to draw this triangle out here so that you can see it. I'm just taking it and making it so that it's something you can see. 11, right? So base times height divided by 2. So then I'm left with 6 times 13 times 11. And I'm just going to put that into my calculator, if my calculator would work. Sorry, just trying to pull up my calculator. So we have 13 times 11, which is 143. I'm just going to divide by 2 right away. So I'm left with 6 times 71.5, right? So I'm just going to do that times 6. And I'm left with 429 is equal to the area of the base, and that's centimeters squared, right? And if I wanted to find the volume, I know the volume is always area of the base times the height, right? And if we want to know the height, we just need to know what this is, and we know it is 29 centimeters. So I'm going to do 429 times 29, right? And then 429 times 29 is equal to, I'm just going to put that into my calculator as well. Is equal to 12,441 centimeters cubed, right? Volume is always in centimeters cubed. Okay, so that's how I would do that one. So I would take a minute here, pause the video, and try and do the next one by yourself. It's a little bit more complicated because we always get complicated as we move on. But I want you to try it out because it's a really great way for you to see that thinking and inquiry piece. Remember when I said that a lot of this is how well you can think about a subject and how well you can problem solve and figure out what you're trying to figure out, right? So try doing that one and then we'll take it up together. So just pause this recording, try and solve it. I was just grabbing my calculator, a better one. All right. So pause it, try it out. Let me know if it works for you. All right, so welcome back. So first things first, we're going to find out, what do we want to find? We want to find the volume. So we know that volume is equal to area of the base multiplied by the height. We know that our height here is 15 because that's what's connecting the two triangles together, right? So let's worry about that after. We need to find the area of the base. So our base is a triangle. So if I go back here and I make this triangle, right, we have our triangle. Now, what we want to find out is that actual height. Because without the height, we can't know what the area of the entire triangle is. I know that this side is 6 because I know that the bottom is 6, right? But what I can do is I can actually use the right triangle right here, like we've been doing, and use Pythagorean theorem to figure out what is the area of that triangle or the height of that triangle so that we can figure out how to find the area. So I have 6 over here. So I have 6 over here. The bottom, I only have half of it. So this is going to be 3, right? And I want to find what this is. So I'm going to say this is B, right? So if I go back and I look at my A squared plus B squared equals C squared, right? What I'm going to do is I'm going to say, all right, what's my A? 3 squared plus B squared, which I don't know yet, equals C squared, so 6 squared. I'm going to multiply 3 by 3 plus B squared, because I don't know that. 6 squared is just 36. Then I'm going to move that 9 over to the other side, so I have 36 minus 9, right? 36 minus 9 will give me 27. This is still B squared. B squared equals 27. I want to get B on its own, so I'm going to square root both sides to cross this out. And B is equal to the square root of 27, which is about 5.2. Now, I know the height of that triangle. So if I want to find the area of the base, I know it's going to be base times height divided by 2 because that's the area of a triangle. That's going to give me base, which is all the way across, which is 6 here. 6 times 5.2 divided by 2, right? So I'm just going to go in, put that in. What does that give me? 6 times 5.2 is going to be 31.2 divided by 2 is going to give me 15.6 is the area of the base. So now I have the area of the base. I'm going to go back and put it into my volume formula. Volume equals area of the base multiplied by height. I know area of the base is 15.6. If I go back up here, I had actually found the height, which was 15. 15.6 times 15 is going to give me 234 centimeters cubed. So we needed a little extra step here, but we knew how to do that because we knew the Pythagorean theorem, right? So we can always find the height of a triangle if we know the Pythagorean theorem and it's an equilateral triangle. Okay, so moving forward, this says, so that was just prisms, right? So we had a very well thought out formula for prisms. Cylinders also has two bases, but they're circles. So because they're circles, instead of having the boxy shape, they actually have more of a rounded shape, right? So they're connected by a curved surface, and the circular base is, the radius is r, right? So the radius of the circular base right here is r. If we went all the way across, that would be d. That's considered diameter. So a good thing to remember here is that radius is equal to diameter divided by 2, right? So if we go here, the first thing we want to figure out is this is a cylinder. So I know that the volume of a cylinder is equal to the area of the base times the height. You still use the same logic. Area of the base times the height. Area of the base times the height. Right? Another way to write this, the area of the base is equal to the area of a circle, which is just pi r squared. So I know volume is equal to pi r squared times height. Right? So I know here my diameter is 6. So if I wanted to find my r, I would say diameter divided by 2 equals radius, which is 6 divided by 2 equals radius. So 3 is my radius. Okay, so volume is equal to pi 3 squared times my height, which is 12, right? From here to here is 12. That's the height of the can. So I'm going to say, okay, V is equal to pi, 3 squared is 9, times 12. And I'm just going to put that into my calculator. I have pi times 9 times 12 will give me, so 9 times 12 is 108 times pi is 339.3. Oops, and I forgot to add in my, this is centimeters because it's going up by centimeters cubed. So if 1 centimeter cubed is equal to 1 milliliter, how many milliliters are in the pop can? It's just a 1-to-1 conversion, so you have 339 milliliters as well. Okay. So part B, volume of pyramids and cones. So I'm actually going to show this video in class, but you can go onto your own D2L, and if you click on the link, it's a hyperlink and it'll take you to the video, right? So we're going to go through this together, but we're going to watch the video together, but I'm going to summarize it for you right now. A good summary of this video basically indicates, and bear with me as I draw these very ugly pyramids, the best that I can, right? Basically what it was saying is that if you have a square-based pyramid, right? So a triangular pyramid, right? And then you have another triangular pyramid, and its base is a square, so that's one thing we need to keep in mind. And then you have another pyramid who has a base of a square. And I do apologize for how not nice these pictures are. right? If you took 3 of those, you'll notice that when the person in the video puts them together, right, it takes 3 triangular-based square-based pyramids to give you 1 cube, right? Oops. That's a little bit better that way. Okay, so if you took a square-based pyramid, square-based pyramid, square-based pyramid, and you added them all together, it would give you a square cube. It would give you a cube, right? So it's safe for us to say, therefore, the volume of one of these rectangular-based pyramids, right, of these square-based pyramids is 1 cube. The volume of the cube divided by 3 is going to give you the volume of the pyramid. Okay? Same thing. So I'm not going to try and draw the cone. Hopefully it looks okay. So if we have our cones here, right? The person was putting together these cones. Notice that if you took 3 cones and you arrange them in a method, right? Took 3 cones and you arrange them in a method, you would get a cylinder, right? Which is just a, you took the top is a circle, the bottom is a circle, right? So, similar to the pyramid, a triangle with a round base, if you put them together, will give you a cylinder, right? So we know that 3 cones, when you put them together, 3 cones, when you put them together, will give you a cylinder. So it's safe to say that the volume of any cone, right, the volume of any cone is equal to the area of its base times height, which is just the area of the cylinder or the area of the prism, divided by, or the pyramid, or the cube, divided by 3. Right? Because if you were to take a cylinder and divide it by 3, you would get 3 separate cones. Right? So, the formula here is area of the base for any cone or pyramid. If you take the area of the base and you multiply it by height, which is going to give us the volume of the prism, right? If you divide it by the height and divide it by 3, you get the area of either the cone or the pyramid. Okay? So let's try to do that one. So I know that the volume of this, because it's a prism or a pyramid, right, is going to be area times the base multiplied by the height. Right? So let's just go in and look at what we have. We know that this bottom here is all going to equal the same, so we know this bottom is 6 centimeters. Okay? I know that it's how many sides does it have? 1, 2, 3, 4, 5, 6. I know it's a hexagon. And I know from from the middle of this hexagon to the middle of the side is going to be 4 centimeters. So I'm looking at that. So that means that I know that my area of a hexagon is equal to 6 times the area of the triangle within it. So it's going to be 6 times base times height divided by 2. My base is just going to be, I'm just going to pull this out. It's going to look like this. I'm just going to make it so that it autocorrects into a triangle. We're going to pretend like this triangle is an equilateral triangle. There you go. I know that this is 6, and I know the height is 4. Okay, so I'm going to do it right. 6 times 4 divided by 2. So I have 6 times 4. I'm going to do whatever's in the bracket first. 24 divided by 2. Still going to do what's in the bracket first. So 6 times 24 divided by 2 is 12. So 6 times 12 is going to be 72. So I know the area of my base. Area of my base, or my hexagon, whatever you want to call it, is 72 centimeters squared. So I want to find my volume. Volume is area of the base multiplied by the height divided by 3, because that's what it is for a prism. I know that my height is from this apex all the way down to here, and I know that's 20. So I'm going to say, all right, volume is equal to 72 times 20 divided by 3, right? So we got 72 times 20 is 1,440, and then that's going to be divided by 3. That's going to give me 480 centimeters cubed. And that's the volume of my prism. There. So try to do this one on your own, right? As always, it gets a little bit more complicated as we move on, right? So pause it for yourself, see if you can try to do it by yourself, and then we will take it up together. All right, so I'm going to give you a minute. Alrighty. So, welcome back. First things first, let's look at what the base is, right? Because we always want to find the area of the base. So if area of the base times height is going to give us volume. So the base is a triangle, which means that our area of the base is going to be base times height divided by 2. We have the base, right? So we know that the base of this triangle seems to be, they're all 8 feet on both sides, so it seems to be 8. We don't, however, know what the height is, so we can't find it just yet. So, like anyone else, I like to visualize this like this, so I'm just going to pull out my triangle and try to work with what I have. Oops. I want to make it look a little bit more like a triangle. So there it is. It's not happening for me right now. Wonderful. Okay, I'm going to stop trying. Okay, so it's 8, 8, 8. Right, so I have 8 feet. I don't know how long the height is, but I do know what the hypotenuse and the base is. Right? I want to find out what this height is right here. So I'm going to use my Pythagorean theorem. I know that this is halfway through, so this is going to be 4. So I'm going to say, all right, 4 squared plus h squared, which is just my b squared, right? So I did a squared plus b squared equals c squared. 4 squared plus h squared equals 8 squared, right? 16 plus h squared equals 64. Gonna move that 16 over to the other side. So 64 minus 16 is what I'm looking at. Is going to be 48. So h squared equals 48. If I want to get h by itself, I got to cancel it out with that square root sign. So h is equal to square root of 48, which is about, square root of 48 is about 6.9. 6.928. So I'm going to write 6.928. Okay, so that's going to be my height. Because I'm being a good math student and keeping as many decimal places as I can without it getting super messy. Okay, so I'm going to go back here and I'm going to plug in my height. So I'm going to say A is equal to 8 times 6.928 divided by 2. I'm actually going to use the ANS feature on my computer, on my calculator, so you might get a different number. So I got area is equal to 27.713. If you got in and around that number because of the numbers you used, that's fine. Okay? So I have 27.713, right? And if I want to find the volume, volume is equal to area of the base times the height. My area of the base is equal to 27.713 times the height, which is just, if you go from here to here, it's 7 feet. I'm not going to write the feet in. Times 7. And I just kept using ANS, so you may have a little bit of a different number. But I got 193. Oh, silly me. 8 times 6.928 divided by 2. And then this is divided by 3. Oops. Divided by 3. I wrote in the formula wrong, sorry. So then I'm left with 27.713 multiplied by height, which was 7, divided by 3. So then I'm left with 193.984 divided by 3. So I'm just going to divide by 3 here. And I'm left with about 64.6. And again, depending on where you rounded, right? 64.7, sorry. Depending on where you rounded, this might be actually closer to 64.5, 64.4. Okay, so just be mindful of the rounding, right? That's why I left as many decimal places as I possibly could. Okay. So, moving onwards. Try doing this one by yourself, or you can watch this one. The only thing to keep in mind here is, what is our base, right? So we're going to look at what is our base to start with. Our base is a circle, right? The circle with the radius of 5. And that's something important to remember. So we know volume is equal to area of the base times the height divided by 3. So first things first, let's find the area of that base. Area of the base is equal to pi r squared, because that's the area of a circle. Pi is just pi. R is 5 in this situation, squared. 5 squared is 25 pi, right? And I'm just going to go in and put 25 pi in. And that's going to give me like 78.539. So I'm going to say 78.54. Okay. That's my area of the base. Now, I want to find area of the base times the height, right? So I want to find this measurement right here. But I actually don't know what this height is. We're not sure, right? We don't know what capital H is. But there's a really easy way to find this. This is something called a right circular cone. Right? And you don't really need to know this, I'm just telling you. It's called a right circular cone, which means that this apex of the cone and the center of the cone, of the circle at the bottom, are in direct line of each other. So when you are looking for the apex of the cone, it is directly perpendicular to the center of the circle at the base, right? That basically means that this, in its entirety, is a right angle triangle, right? So we can treat it like that, which means that now I have this A at the bottom, this C over here, and B is basically the height. So what I can do here is I can do A squared plus B squared equals C squared to find the height. So I know A is 5 squared, my B is the height, right? Equals C squared, which is 13. You can't see it very clearly on this, but it says 13. It'll probably show up more clearly on your actual handout. So then I know 5 squared is 25 plus h squared, so I'm just going to leave that alone, plus 13 squared is 169. I'm going to move the 25 over to the other side, so I'm left with h squared equals 169 minus 25, right? h squared is left to be 144. In order to get that h by itself, which is what I'm looking for, I've got to square root both sides to get rid of the squared for the h. So h is listed is 12. So it's 12 centimeters. Okay, I'm just making sure that I had the right units. 12 centimeters. Okay. So I know that my volume is equal to area of the base multiplied by the height divided by 3. And now I got everything I need. I know the area of the base is equal to 78.454. I know that my height is equal to 12. And I got to divide that out by 3. So I'm going to say 78.54 times 12 is equal to 942.48 divided by 3. Oh, that's not good. Divided by 3. Right? I'm just going to divide that by 3. And that's going to give me a volume of 314.2 centimeters cubed. Okay? And that's my answer. And now, last but certainly not least, right? We're using the same logic. Same logic as we used time and time again. Please try to do D by yourself. I'm obviously going to walk through it with you right now. But again, you can go back and just watch this yourself. Okay? So a few things to note here. This bottom, this is a square. Right? So I just want to point that out, that it's a square. Oops. It's a square. I'm going to make the square look a little bit nicer, maybe. I don't know if it'll correct to the right size. It won't. So I know that across, this is 12 centimeters. Right? So that means it's 12 centimeters here. That means it is 12 centimeters here, and then it's 12 centimeters here. Right? I know that going upwards like this, so I'm going to make the triangle in a little different color maybe. So I know going up like this, the hypotenuse of this triangle is 10 centimeters, right? We don't know what the height is yet, but that's okay. Do we know what this little purpley line at the bottom is? It's about halfway through, right? The apex of this is about halfway through, right? So we know that that bottom part is just half of 12. So that's actually going to be 6. So we know that's 6. And we know this is 10. So I have basically my A, my B, and my C. Right? In the chance that I need it in the future. But first things first, let's find the area. The volume is equal to area of the base multiply by height. Area of the base here is really easy to find. It's just the bottom square. What's the area of a square? 12 times 12 because it's just length times width. Right? I know my length is 12, my width is 12, so I'm just going to do 12 by 12, which is going to give me about 144. Not about, it's actually going to give me 144. So I found my area of the base. Remember when I said you might need that height? Yeah, we do need that height because we need to know what the height of this pyramid is. So, in order to find volume equals area of the base multiplied by height divided by 3, right? To go off and find this height, we got to do a little bit of work, right? So what I'm going to do is I'm going to actually pull that triangle out. I'm going to say, all right, I work better with triangles that look like this, so I'm just going to pull it out and work with it on its own. Okay, so let's see. The bottom is 6, the side is 10, and we're trying to find this height. Right, so I know this is A, or B, doesn't matter what you name it. That one has to be C, the 10, and this is going to be B. So I know that A squared plus B squared equals C squared. A squared plus B squared equals C squared. So I'm just going to start putting stuff in. A squared plus B squared equals 10 squared. 6 squared is just 36 plus B squared. And again, if you need to use your calculator, power to you, go for it. I just can do this in my head. So 36, I want to move it to the other side. So B squared is going to equal 100. minus 36, right? 100 minus 36 is going to be 64. So I know b squared is equal to 64. I want to get rid of that squared because I want b by itself. Square root both sides. B is going to go square root of 64 is 8. Trust me, I listened to enough Drake to know that. So volume is equal to AB times the height divided by 3. And now I have all these numbers. I know my area of my base is 144. 144 multiplied by height, which we know is going to be 8, divided by 3, right? Volume is equal to 144 times 8. So I'm just going to put that into my calculator. It's 1152 divided by 3. Volume is equal to 384 centimeters cubed. Okay, so it's a little bit of work, but you can get there. And again, we're focusing on those problem solving skills, right? And that's what we're really looking for. And that is the end of lesson 3.